I hope everybody's doing safe at home, and hopefully, you're finding more time compared to spending your precious time coming to a class, and maybe spend some time at the traffic. Rather, you'll be comfortable and spending more time doing your studies. So I just want to quickly recap. Today we are starting the second session on lesson number one. We are on the data collection, information, types of data. And today we are touching the final part on the lesson number one, that is the sampling methods. But before we move forward, as a habit, I usually spend around 3 to 5 minutes every day, and I am recapping what we did on last week. This is just to keep your brain refreshed as to what we have done in the immediate week, as well as to show the direction that we are moving on. Okay, so let me just take a couple of minutes and just brief you on what we have done last week in a very nutshell manner. Okay. Right. I hope you can see the session outline slide of the last week lecture. This is lesson number one, lecture number one. Students, this is where we took a very basic introduction to our deep subject area on the statistics and business mathematics. So where I have given you some introduction into these very basic types of subject outline. First, we had a discussion on what is data and information. We realized that data is nothing but raw, unprocessed items, and when you convert them into a meaningful manner by using of a particular process, we call them as information. We did a couple of good exercises to understand what form of items can be identified as data and what form of items could be classified as information. For example, if you could recall the rainfall example, if you consider the exact rainfall for 30 number of days, those items in millimeters, those are data. But if somebody gives you an indication as to the average rainfall of a particular district in a particular month or a particular week, that is information. So that's the basic distinguishment between the data and information. Then we had a detailed discussion on the types of data. We understand that there could be primary data and secondary data based on the source of data. And on the sources of data also, we discuss into detail. If at all, if it is a primary source where you can cultivate based on a research methodology, you keep it as primary. Whereas if somebody tries to give you a data set from an already developed source or already published source, that is nothing but a secondary source of data. And we stopped last week class by giving you a very basic introduction into there's something called a population, uh, which is the entire set of items or people or households or let's say types of different elements where you may not in a position to have all those items or people to do your statistical analysis due to various reasons. It could be due to uh, non-accessibility, due to the cost factors, due to the timing, due to not availability. So there only this beautiful concept of sampling comes into play. So we realized that if you denote in a very brief manner, capital N would be the uh, denotion which we can give for the population, while simple n will be the notation that can be given to the sample. So bear in mind that whenever, there will be some equations also when we are going for our advanced calculations on lesson number 3 onwards, yeah, we will be using this notation, capital N and simple N always. So whenever there is a population and a sample related data, just bear in mind that they're using the capital N for population and simple N for sampling. And last week we stopped our class by giving you a very brief introduction to the sampling methods. We discussed that there could be probabilistic and non-probabilistic sampling methods, and there are around 8 distinguished methods that we are studying under this curriculum, which are the widely used methodologies. But bear in mind that these are not only the sampling methods, but there could be many more advanced methodologies. And then we had a very brief introduction to a couple of past paper questions in the recent past. And you could easily understand that even by just covering some of the content in the very basic introduction lesson, there are some questions like question number 8 in your paper. Based on the past examination papers, you can understand that there are some open-ended questions like do or compare and contrast, or by means of writing some characteristics of type A, type B kind of it, maybe somebody's asking about primary versus secondary sources of data. Likewise, there are some easy questions you can tackle from this section. And with the today's knowledge that you're gaining on the second lecture, we are touching upon the sampling methods. We'll be discussing exactly 8 sampling methods in detail. You will understand why these sampling methods are there in the world, and why we are using them in what instances, and how to use them in a correct manner. One could argue, when there's a population, there's no necessity to look for these different methods and bang our head on the wall and try to come up with different methods and select samples based on these methodology. But you will understand when we continue our discussion on to the latter part of today's lecture that depending on the scenario, you as a researcher, you as a mathematician or a statistician have to make a call in selecting a small set of elements from an entire population in order to make a judgment, to make a decision based on your collected data. So all the time you have to make a smaller group focus and channel your questions to that group, get the responses, and then determine what is the answer for your particular question that you're looking for. Okay? So that is the last week's summary. That is where we stopped last week, and the continuation is uh, this number 6 I have highlighted here. That is a sampling methods, and this is the entire session that we are going to spend these 2 hours with the continuation on to the last week. Okay. So let me, with that introduction, or rather with that recap on the last week lecture, let me take you to the today's lecture slides, which I hope you have already downloaded and ready in your computers. Okay, right. So this is the lecture number 2. We are still under the lesson number 1, same topic. This 1 out of 11 we are covering. These are the contents that we will be going through today. These sampling methods that I discussed, we will discuss in detail what those are. Section number 2 and 3 are the 2 broader branches that we are classifying these sampling techniques, one under non-probabilistic, second under the probabilistic. Then after the detailed go through of these 8 particular sampling methods, you will understand that still there could be some possible issues with sampling. Even if you do your best to select the sampling method and select a simple n from the capital N, but still your study or your research may be incomplete, or maybe it could be moving into a leading end. Your decision set would be biased because of the issues that is surrounding sampling, irrespective of the method that you're selecting. So that is also, just keep a small mark over there. That is one of the favorite areas of the questions raised in the past examination papers by your previous examiners. So there we will have a brief understanding on a couple of specific names are there, like non-representative. You need to understand when the examiner mentions those words, that is coming under the sampling subject area, specifically asking on the sampling issue. Okay. And then we will wind up the day with some of the previously tested past questions. So unlike the last week, now this week, we'll have a couple of MCQ questions also. Those are very interesting MCQ questions. We will go through together, and you will understand the level of depth your examiner is expecting you to perform at the examination. Okay. With that introduction on the content, let's move ahead with today's lesson on the sampling methods. Okay. So we already have a stepping stone into the sampling methods. we understood that there are all what we're trying to do is to do a selection of simple n from capital N. So broadly, those sampling methods could be classified into probabilistic and non-probabilistic sampling methods. As the word gives you an indication, if you look at these words of probabilistic and non-probabilistic, this should give you an indication, right? This particular set of sampling should be coming under some sort of a probability-oriented selection criteria. So that means we should be giving opportunity for the items in the population to be selected to the simple n based on an equal probability or a selected probability or a cluster probability. But coming to the other branch of our discussion on the non-probabilistic sampling. So as the name sounds, it should be the case where we're not giving a probability-oriented chance for the items in the simple lane to be selected as the sample. Rather, we will be doing some biased selection. That could be based on the preference, maybe the choice, maybe due to the accessibility. For instance, let's say, I'll take a small example. Now, let's say you want to do a particular sample on the nutrition level of a couple of villages in Sri Lanka. But let's say few villages are located in a very extreme remote area. You have to go by a bus and then maybe go through some muddy roads, and then maybe some villages maybe across a mountain, some villages maybe in an island across the ocean, like in the northern area. Due to various reasons, depending on the budget and the time allocations, you may not in a position to reach all these villages and collect the data. So even maybe 50 villages, you may have to uh, deliberately, omit couple of villages due to the non-accessibility. So that's a classic example of a non-probabilistic sampling method. You can't merely, say, okay, my let's say my superior has given me this 50 list of villages, and then I have to give an equal chance to all these villages. But those villages in those remote areas, you may not in a position to access, irrespective of uh, whatever the willingness that you have. So that is the basic idea of this non-probabilistic sampling. So uh, whether you want to give an equal chance, maybe due to various reasons. Now the convenience or the access is one of the examples that I quoted in my village example. So likewise, there may be various preferences of your researcher's perspective. So depending on that, you may not in a position to go for equal probability oriented simple n selection. So that's why this other branch of sampling is also there as the non-probabilistic. So if we go by one from the names, the first one is we name as the convenience sampling. Second one is judgmental sampling method. Third one is quota-based sampling. Fourth is no. So these are some of the very famous non-probabilistic sampling methods. But bear in mind, children, now these are not the only non-probabilistic sampling. If you do a bit of a literature review, you may find that there are more areas into these non-probabilistic sampling. There are many other names, but these are some of the recommended things to be considered from your lecture's point of view. Sorry, from your curriculum point of view. Secondly, these are the sampling methods when we are considering the probabilistic oriented sampling, namely simple random. The name is suggesting that we are giving some random opportunity to everybody. Systematic, so sort of like we are organizing in a systematic way and trying to select. Stratified and cluster, both are we are trying to put them into some sort of a grouping way and then select a sampling. So broadly, this is what we are going to study today, what these sampling procedures or methods are, and what sort of uh, differences and similarities that you can see under each of these sampling methods. Now, before we move on to each and every one, let me just give you a indication as to when you're looking at the questions on the recent examination paper, you may understand something very interesting is such that now there are very thin margin between some of these sampling methods. For instance, if you take names like quota and stratified, or stratified and clustered, there will be very thin margins. So it's the perspective of how you read the examination question sometimes can lead you to a dead end also. So if you have to bear in mind that whenever there's a question coming from the sampling, you have to always think that, okay, I am supposed to do the simple n from capital N. That is my exercise. We don't intend to go and talk to the entire capital N. If it is possible, there is no necessity for the sampling methods or sampling to be tested. Isn't that so? So there's no point of simple N selection provided that we have the accessibility to the complete capital N. No. So the examiner's point of view, just try to think always, right? If I'm to select a small group of items and do my survey, then what am I looking at? Am I looking at a probabilistic oriented way, or am I not giving equal probability? Or if at all I'm giving a probability, then whether I'm going for a clustered or a simple random, so that is purely up to you to argue and cultivate the correct answer. Okay? So be careful, specifically at the MCQ question, right? Okay, so let's take one by one. So the non-probabilistic sampling, this is all what you have to keep in mind. You are not essential. You don't need to essentially know information about the population. What do you mean by this statement? That is, if at all you have some detailed idea as to this is my entire population, so then in that instance, you may be in a better position to use a probabilistic oriented sampling method and do some clustering, do some systematic organizing, and then select simple n items. So hopefully that you are going to cover the entire spectrum of representation from capital N. So that is also important. You have to understand that by doing a simple N selection from the capital N, our hope is 100% representation of items in the capital N from the simple N that we are going to select. But in practice, in reality, you may not reach 100% at all the time. With a very lesser probability, sometimes your simple N will be a greater representation of the entire population. But in reality, maybe 92%, 91%, maybe 90%, or in some weak cases, maybe 70% will be your best chance to get the perfect representation to your simple N, right? So coming back, non-probabilistic sampling is again where you don't necessarily need to have some idea about the population. So what sort of population these are? Let's say I'm going to tell you to select the, let's say approximately 22.6 million is our population currently in Sri Lanka. I am giving you the population as all the Sri Lankans. So do you know the entire set of information about this 22.6 million population? That's not the case. It's very difficult, isn't it? So, but if you could recall our class example yesterday, we assume, let's say we have 70 students in our class. I'm going to invite you to select a sampling method based on your choice. You could go for a probabilistic or non-probabilistic. But compared to that 22.6 million population, when you are discussing about the 70 student in your class, there is a greater chance that you know information about the population. You know the total is 70. You know the male students and the female students. You know the age group that they're representing. You know the geographical areas that they're coming from. Various information could be derived in the population, maybe due to the smaller size. So non-probabilistic sampling, just bear in mind, maybe due to a larger population, maybe due to people that you don't even know should be coming into the population. Let's say your population will be all the A positive blood group holders, A positive blood group holders. So in that case, we're talking about a 6 billion population in the world. So not like that 22.6 million population. In this case, maybe you're designing a questionnaire online and you're sending it to all the A positive people to be truthful and fill it for you. In that case, you may absolutely have no idea. Maybe the population will comprise of people from India, USA, Mongolia. It could be many countries. So that is the classic case of the birthplace of non-probabilistic sampling. So you don't necessarily have an understanding about the information on the population or the items in the population. So bear in mind, this is the idea of the non-probabilistic sampling. This is a sampling method where it is not possible to specify the probability that any person or any unit which the survey is based will be included in the sample. Because of that, you don't know much information on the entire population, so you can't merely give an equal weightage or equal chance for anybody to be included in our sample. So key advantage is to select samples in a purposive manner. So that means when you are going to do some selection, you don't necessarily have to be a lot of preparative, do some systematic organizing or clustering and then go for the sampling. It's not like that. So you can merely go with a very purposively selection of sampling. So if you look at some of these names suggested convenience judgmental, you will have an understanding that what do you mean by this purposive selection. We will touch upon that. Second point, enable us to reach members in the population in a more flexible manner. That is the entire, this word flexible suggests the idea on the non-probabilistic sampling. So if it is very rigid, then in our 50 villages example, if your researcher or your superior is insisting that you have to, go and give equal chance to these 50 villages and select maybe 5, and in that case, you will be in a lot of uncomfortable position to collect the data set. So those are the broader advantages. You can purposely select the sample the way you want, and you have a greater number of flexibility to select your sample. Some of the disadvantages. It's difficult to make a valid estimate about the total population because the sample selected is not representative. Keep a small underline here for the word not representative. What do you mean by the word not representative? So provided you went for a probabilistic sampling. So this definition on the first bullet point says that you can't, or you are not in a position to possibly say that equal probability shall be given to individual elements to be selected in the sampling. But when you go to the probabilistic method, it's the same opposite side. It says that you will be giving an equal probability for the items in the population to be selected to our sample. So that itself is the major distinguishment between the probabilistic and non-probabilistic. So the non-probabilistic method will always carry this greater problem of non-representativeness. So that means uh, depending on the selection method that you pursue to select your sample, there is a greater chance that the selected sample will not have some elements from the population. Let's say, uh, let's try to see a classic example. In our 70 students class example, let's say, now there are, let me select a qualitative characteristic like there are people who are into aesthetics, okay? Some people may like music, some people will like drama or arts or maybe literature, whatever the aesthetic that you prefer. So you don't know, at this case, let's say you don't know what their preferences are. And you're going to do a small survey onto the mathematics knowledge, correlation or covariance with the aesthetic subjects that they are following. So if you went for a non-probabilistic sampling method and select a couple of chaps from your class, that means you don't know information about your population and you handpick. Let's say from 70 students, you're picking 5 students. Okay, there's a greater chance that all 5 of them are music lovers, or let's say their hobby is music. So in that case, when you do your study or the survey, you're missing people who are into arts, painting, dancing. So in that case, this key disadvantage of the non-probabilistic method is there again and again. That is, your sample or the simple n does not represent the characteristics of the capital N. So in our example, in our this discuss example, for your simple n to be incultivated, what you should do is that you should first have an understanding about the 70 students, maybe have a show of hand who likes music, who likes dancing, who likes painting, and mentally have some sort of a classification. And then if you still use some sort of a method to select a couple of people from, at least let's say one from art, one from music, then your simple n will be a very broader representation of the entire capital N, because you see, because a sample now consists of one person who likes music, let's say two person who likes dancing, and one person like painting, and one person maybe with literature. So broadly, in all these four next sampling methods that we are studying under the non-probabilistic, we'll have this greater disadvantage. That means always bear in mind that the moment it is non-probabilistic, your simple n will not be representative. That's not a 100% statement. There's a random chance that your simple n may have all the elements. In our five students selection of this 70, there's a chance that randomly, unknowingly, maybe you will uh, select from maybe five different subject areas, but that is a remote chance. But the greater probability is there to be uh, that sample to be a biased sample. Okay. So with that introduction onto the non-probabilistic, let's study one by one and try to understand what these are. I put up some small diagrams to be very easy for you to memorize these sampling, rather by heart the definitions. The first one is convenience sampling. We'll read through the text first. Members of the population are chosen based on their relative ease of access. Okay. You have the red earmarked human being here, that is the researcher. And you can see that this blue line selection is the simple n, and this entire human beings marked in green, purple, and yellow are the population. So this this line which is earmarked from the blue area is nothing but the selection. That is a simple n. So the moment if you look at this diagram, what you could see is that, okay, researcher seems to have selected the human beings which is close to him, which may be convenience to him. So this is a convenience sampling. Has he reached people from this corners, from this extreme right corner, extreme left corner? No, it seems not the case. And interestingly, look at this text here. No purple figures are in the sample. Isn't that the case? So in this population, you may see that there are purple color human beings, blue color, green color. So he has selected this sample of 4 out of this, let's say 17. Selected this 4 based on the convenience sampling methodology, which means these are very close to him. These are very accessible to him or her. Unfortunately, from this selection, you may understand that purple human beings are not included in this sampling. So if at all he's doing a study on the behavior patterns of these human beings in this uh, capital N population, then we should understand that this purple human figure is missing. That means the data from purple area will not be taken into the consideration for the study. So as the diagram suggested, this is nothing but the convenience sampling. So the broader idea is that ease of access. Keep an underline here, ease of access. Relative ease of access is the keyword to remember. Convenience is nothing but the ease of access. Second point, analysis can be conducted by what was convenient, not by random. Okay. If at all he is going for a random selection, then he should not worry about this blue earmarked line here, but rather he should tackle with maybe extreme right corner, maybe extreme left corner, or maybe a couple of people from the mid area. But that seems not the case that convenience sampling is suggested. So this can be, I mean, the analysis could be conducted on the convenience set of items, but not the randomly selected items, also called as haphazard or accidental sampling. Okay. So broadly, convenience sampling is nothing but depending on the ease or the relative accessibility, then selecting a small set of people from a greater number of people. So the diagram suggests the entire text. Okay. The second one, this is called the judgmental sampling. So this is another form of convenience sampling where items are handpicked from the accessible population. Okay. Now, if you look at the researcher here earmarked in this from this human beings notation, so this is the set of population. So the judgmental, the only difference between the convenience and sampling is that judgmental, it seems to be another convenience sampling, but we give the special name judgmental. That is because that when the researcher selects the sample based on his judgment, his or her judgment. So when this population is presented to him, now unlike the previous case where you know only talk to the close by people, in the judgmental sampling, what you do is based on your instincts, your gut feel, or your choice, you select whatever the items to be put on the sample or the simple end. When you look at this selection, you may see, let's say there are around 12 people here, and here you want to select the 33% or one third to be the sample. So maybe he has selected two gentlemen and two ladies. Maybe, you know, as suggested by the diagrams, maybe the geographical or ethnicity, maybe the religion. So depending on whatever the circumstance the researcher prefers, you can select the sample. So broadly try to understand the difference between the convenience and sampling. Convenience is nothing but the sample is selected based on the ease of access. So you may miss some of the elements deliberately because that you're not in a position to reach them. But judgmental sampling, on the other hand, is nothing but you are hand picking, sort of like head hunting. You're selecting items from the accessible population. So previously accessible population, but the very ease of access. Here, from the accessible population, you're hand picking items. Look at the second point. Researchers select items that are representative from the entire population. So he thinks that this will represent my population, but that is judgmental. Why? If you take out this researcher, this B.Ed fellow, if you take him out and if you put another fellow here, this selection will be a total different selection because his judgment on this particular study will be somewhat different from the current researcher. And if you, let's say, put up a lady here, this set of 4 people will be somewhat further different. So that's why it's a very subjective sampling method. So depending on the researcher, depending on his or her preferences, your sample could be totally changing from one person to the other person. So that's why it says finally in this bracket, it can be biased. So what about the previous one, the convenience sampling? Is it non-biased? No, this is also biased. So all these 4 that we're discussing under the non-probabilistic can be biased. Bear in mind. Right. That's on the convenience and judgmental. We'll move forward. Third one, quota sampling. This is an interesting method. Let's look at the text first. Similar to stratified sampling. Now, this stratified sampling is a probabilistic method that we will be studying a little later on the probabilistic branch. Okay? So similar to stratified sampling, but I just want to highlight that these two are very linked and we have a very thin margin here. Right? And the population is divided into mutually exclusive subsets. Now, this word mutually exclusive is a word that we are using quite often at the probability lesson. So nothing to be feared about. Mutually exclusive mean is nothing but uh, you cannot have the characteristics that you are looking for, a particular characteristic that you're looking for, duplicated in a selection. A classic example will be males and females. If you classify them into two, you can't have males in the female quota and the females in the males. They have to be distinguishedly put together. Let's say sugar and wheat, you can't mix them together. Sugar has to go to one side, wheat has to go to the other side, likewise. So the quota word is suggesting that we are going to give some representative chance, quota, a chance to be selected in our sample. Okay. So the first step is you have to segregate the population or divide them into mutually exclusive subsets. Look at this population, a small example I have put up here. It says 50% male, 50% female. Now let's count them and see. We have 1, 2, 3, 4, 5, 10 males here and 10 females here. So that seems to be correct. 50% male, 50% female in this population. Okay, this is still the population, this left hand side area. And 70% white people and 30% black people. So out of 10, so further you can see these shaded human beings are the black and non-shaded seems to be the white. Similarly, in the female population also. And then when you look at the quota, you may see that this particular selection that I have covered under this example, okay, they have selected 4 out of this 20 population, and 50% of males and 50% of female quota is being given. And further, if you carefully look at it, further you can understand that an equal representation to black and white are also given. But if you selected these two and only white males and black females, so that may not be the correct representation. So this researcher seems to be trying to give a fair representation on the population. So when you look at the population, you have 4 distinguished types of particular quota that can be visually seen in this particular sample, but the population. So when you are defining your quota, you want to give an equal chance to everybody, isn't that so? So when you're given the chance, you can clearly visually see that one black human being is there, one white human being is there, one black female human being is there, and white female humans. So the representative gender distribution in a population and not representative of the rest. So this particular researcher's intention is to give the representation on the gender 50-50, but further he has given the equal quota to each of these particular distinguishment of black and white also. So further, I just stopped from the first bullet point. Further, let me cover the couple of other bullet points also. Then judgment is used to choose the items from each stratum based on a specified proportion. So in this case, 50% males are there in the population, 50% females are there in the population. So it's the same has been given. He could select 25% of males and 75% of females. That's not a problem. So the population will have a specific distinguishment of a proportion of 50-50, but in the quota you can do your choice. Why? Still we are under the non-probabilistic method. If it is probabilistic, children, we have to be careful. If it is probabilistic only, now this stratified method is suggesting that each stratum should be given an equal probability to be selected. But here still sort of like a judgmental. He selects 2 males and 2 females, and then to be better, you can do your selection by 1 white and 1 black under each this segment. See, so the quota is nothing but when you divide your entire population, entire capital N, into some previously known characteristics, and then for those distinguishments, give some selection based on your choice. So the last part is the only distinguishment between the probabilistic method and the non-probabilistic method. If you could recall, now let me just take you back to a couple of slides before. Not essential to know information about the population. So that's the keyword that we started. Not essential to know, but when you come to the quota sampling, the population should be divided into mutually exclusive searches so that you seems to need to understand some characteristic to divide this population. But still, once you do your quota, you don't necessarily give an equal chance for the each of the elements to be selected. That is why we say the quota sampling is a non-probabilistic, while when we are going to the stratified sampling, I will iterate that it is exactly similar to quota, but the only difference is that you will be given an equal chance, equal probability to be selected to the simple n. Okay. Last point, difference between the stratified quota is where the stratified requires random sampling for each strata, while quota does not require as so. The word random sampling suggesting that we are giving some sort of an equal probability for the individual element to be selected in the quota, not a particular judgment, not a particular perspective, not a particular choice. So that is why the quota is suggested as quota. Okay, we covered three already: opinions, judgmental, and quota. Last one that is under the non-probabilistic is snowball sampling. So as the name suggesting, this is a very jolly well sampling method to understand, keep in mind, like a snowball. Yeah. Do you know when an avalanche or a snowball falls down from a top of a mountain, what it does is it goes and attached to more snowballs or more snow elements, and it becomes bigger, and then it becomes further bigger. Maybe one snow element will get an attached with four more, and then you have five elements together. That five will get attached to 10 more, and you have 15 in your snow attachment. So 15 will go and get hitched with maybe 25 or 30 more. Likewise, exponentially your sample will become bigger and bigger. The snowball will become bigger and bigger. The exact same methodology or the concept is the definition of the snowball. This is a non-probabilistic sampling method. That means you're not giving the items in the snowball to be equally selected. I mean, the snowball doesn't go everywhere and try to hitched up with each and every snow element and try to give a fair chance to everybody, but it will flow the way that it will moving on. So this non-probabilistic method is where an existing study subjects recruit further subjects from among their acquaintance. So that means, let's say, a classic example will be you design a particular questionnaire. Okay, then now this questionnaire, let's say, is about a couple of friends who are doing MBAs, and you want to assess their particular knowledge on let's say macroeconomics or accounting. So you assume that everybody in the MBA programs will have this in their whatever the semester, 1, 2, or 3, and you want to assess that among MBA student population in different campuses, state campuses, private campuses, this particular element of knowledge. Okay, so you design a questionnaire and then you forward it to one of the friends who are doing an MBA in maybe University of Colombo, ICBT, or any for that matter. Then once that person receives this questionnaire, he or she will fill this for you, and you send a small message saying, if you could help me, can you forward this to a couple of your friends who are doing the MBA program with you. Now that is the birth of snowball sampling. You select one subject, and then that subject can recruit further subjects, further human beings, or further items into your sample. Then what he or she will do is they will forward that questionnaire that link to a set of MBA friends that her or his acquaintance can bring in. So, once again, can you say that there's an equal chance of the entire MBA student population in Sri Lanka to get that link? That's not the case. So you select couple of existing subjects, and then they will keep moving this snowball until it becomes a bigger and bigger sample. So then when you maybe reach 50 questionnaire responses, you will call it a day and say, fine, I'm happy with the sample and my study is concluded. Second bullet point, this sample group grows like a rolling snowball where the first respondents refer to a friend, the friend also refers to another friend, and so on. So that's why in this small diagram is also saying this gray color person will refer to two blue color person and this light blue color person, and they will again refer to another three. These three will send to another two or three or four. Likewise, this snowball, this entire set is the sample that we are selected from a very bigger population. Okay. So recap, we learn four non-probabilistic sampling methods: convenience, nothing but ease of access; judgmental, that means from the sample you can select a particular set of elements based on your perspective, based on your choice. Quota, you try to distinguish everybody into the entire population into some groups depending on a particular factor that you know, and then you don't give them some equal chance to be selected, but rather you choose whoever who comes to the quota by giving a predefined quota. It could be, like in this example, it could be 50-50 or it could be 70-25. It's up to you to select the quota. And then you will be the person, the researcher will be the person who will select the items into the quota sample. Lastly, snowball is nothing but like a giant snowball. The first recruit will select the next recruits, and so on and so forth. Your population will give you a small set of sample based on the uh, acquaintance of the next recruits from the previous recruit. Okay? So that's about the non-probabilistic sampling methods. Try to not by heart this definition, but keep a simple sketch of these diagrams in a corner, and then have a broad understanding on what each of these words is suggesting. And then when you are being invited to write up at the examination, elaborate your answer around the concept. Don't try to by heart this line by line. That's not the expectation from you at this level. Okay? Secondly, let's discuss the second branch of the day, that is the probabilistic sampling. So the entire discussion we had up to now was on the non-probabilistic sampling. So this flip side of the coin is nothing but the probabilistic sampling. We said in the previous instance, it's not essential to know some information or data about the population, but here under the probabilistic sampling, you need to know some information about the population, maybe not the complete set of, let's say, if you're talking about a human being, maybe not the blood type, maybe the gender, maybe the height and weight and various characteristics, but maybe few characteristics that you are focusing on. Those data and information you need to keep in hand prior to conducting a sampling exercise. Okay? So bearing that definition in mind, let's see what probabilistic sampling is all about. Certain items of the population under consideration can be underrepresented or overrepresented. To minimize the above selection bias, target population has to have an equal opportunity for selection. So the previous entire argument set on the non-probabilistic sampling, we discussed that when you're doing a when you're doing a sampling exercise, if we went through the non-probabilistic method, there could be non-representation of items in the sample from the population. But this probabilistic sampling comes into play to give some answers to this question on representation. So that's why the first bullet point is suggested in sampling methods. Certain items can be underrepresented or overrepresented. So in our class example of selecting 5 students from the 70 based on the aesthetic subject that they prefer, if you randomly select 5 chaps based on the convenience sampling, let's say 5 chaps are seated in the first row. You're too lazy to go to the last row, so you just based on the convenience, you ask the first 5 to come and answer the questions and give some responses to your study. If you do that, there's a element of underrepresenting or overrepresenting. So we call that the selection bias. So the target population has to have an equal opportunity for the selection. That 70 students, if I randomly goes in between the class, and if I eyeball at everybody and try to give an equal opportunity to everybody to be selected, that is the birth of probabilistic sampling. That means every item in the population is given an equal opportunity to be selected in the sample. So the rest of the 4 sampling methods that we will be discussing under the probabilistic will have the same characteristic. That means equal opportunity, equal probability will be given for the selection. Okay. So let's look at the first one, the simple random sampling. So this is the most widely used, I would say, sampling method that is available in the research jargon. The simple random sampling. This is one of the most prudent methods to be selected, say provided you are looking at a population of maybe thousands or chaps, and then you need to select maybe let's say 50 or 100. So in that case, uh, if you name all these 1,000 and then use one of these methods to identify that 50, that is nothing but simple random sampling. Read through the text and try to understand what this is trying to say. All items of the population under consideration have the chance of being selected. The probability is equal of everybody. For example, you can use a random number table and pick n number of fairly random selections out of population capital N. Example, using a random number table, select second and eighth item of the population to build the sample. So what does this say? Look at this entire population of 12 chaps that is earmarked here. We have numbered them by 1, 2, 3 and up to 12. Then if you take your calculators out, there's a function called random number in the with a hashtag and rand. If you press that and press equal, you may find that, I mean, depending on the calculator model, your functionality will be different. The calculator will give a decimal number between 1 and 0. The first instance, you may be getting 0.7. Second instance may be getting 0.172. Likewise, it's a pure random number. There is no particular basis to be selected. The simple random sampling suggests that it's like a lottery. You don't necessarily know the number to come into the play, but you randomly select a couple of numbers, and those number holders will be taken into consideration for the sample. Look at this selection. These numbers 5, 2, 8 and 10 are being selected from our random number table. So that means so we know that there are 12 items in the population, but our, let's say, the roulette or whatever the selection criterion, maybe your calculator, maybe like this lottery machine where you will be given random numbers, will suggest you these numbers, number 2, 5 and 8 and 10. When these numbers are there, you will call them. Can I have number 2 please? Can I have number 5, 8 and 10 please to come and sit in this area and answer my questions for my study. So how did you get these numbers? It's by a pure random method. So that random method to select these 4 chaps out of 12 Has anybody decided previously? Can the researcher, manipulate this selection? Can the researcher say that I'm going to give some weight to number three and number seven, and for sure they will come into my sample? You can't do that. You can't do that because the selection method, this random number generation method, has to be perfectly random. That means there's no chance at all to somebody to temper that. But in previously, if you could recall in our discussion on the non-probabilistic method, right, quota and convenience, the researcher has ample opportunity to select the sample. But here, the selection of 2, 5, 8, and 10 position are based on a random number generating mechanism. So that is a broader understanding on the simple random number sampling. So that this, uh, why do people call this as a good sampling technique is that unknowingly we give equal chances to everybody in the population to be selected in our sample for the study. But can you say that this is a perfect methodology? You can't say. Randomly, let's say, now in this nice example, you have two EMF as a black element and this number 5 as a gray element, number 8 as a black element, and number 10 as a white element. But what if random number table is giving us 2, 4, 6 and 8? Then this population will be entirely covered with the darker element of 2, 4, 6, 8. What if it gives you 1, 10 and 12? Again, we could eyeball it and say, it seems to be a biased sample that has been selected from this method. But that is the whole idea. In the random number sampling selection, there is a, I mean, in there's a there's a methodology called permutation and combination, Sankarana Sangyojana in Sinhala. Uh, I mean, when you want to select these 4 items out of these 12, there are multiple methods. We call it the 12C4. There could be maybe around 70 or 80 different methods to select this 4 in this particular example. So some of them will be still biased. So still you can have this doubt in your mind that this is also not going to be a perfect methodology. None of these 8 methods are perfect. You have to bear in mind. But the simple random is one of the most popular methods for the selection of the items in a random way and then forward a question. Now in this case we have only 12 and we are selecting 4. Now this error percentage of selection or the biasness could be greater. But what if we have 12,000 and we are selecting 40? In that case, this could be a perfect methodology. So when your capital N is becoming larger and larger and your simple N is become a very focus item, focus number of items, maybe 1/10 or maybe 1/100 of this size of the capital N. So this could be one of the greatest methods. Why? Because that there is a greater probability that your selection is going to be perfectly random, no biased, and there will be a fairly good number of 40, 50 chaps in your sample for the study. Okay. We'll see what this other couple of probabilistic sampling methods are. The second one is called as the systematic sampling. Systematic sampling. Let's see what this is. Researcher can determine the sample size, the simple N from the population capital N, and determine the sampling fraction. That word is given in quotes. That's the whole idea of the systematic sampling. That means you are going to define what is my proportion. So in the previous example, I said that what if we had 12,000 and what if we are going to select, let's say 120 out of 12,000. So that is going to be 1%. So we are giving some 1% fraction or 1 divided by 100 as the sampling fraction that is predetermined by you or the researcher. So how do you determine this fraction is by dividing the total population. That means that 12,000 by the required sample size. So in that case, I decided it is going to be 12,000 is my capital N size and 120 is going to be the size of my simple N. So the sampling fraction is 1 divided by 100 or 1%, or merely you can say I'm going to select 1 out of 100 for my simple N to be N cultivated. So this target population divided by required sample size shall be used to calculate the sampling fraction. What do you mean by that? Look at this example. Don't try to make things complex. For example, an airline has 400 passengers and 50 would be the sample size. Using systematic sampling, it is suggested to pick every 8 passenger on a sequential order to build our sample. That is the catch here. You have to put things in a sequential order or a systematic manner or a tabular manner or a whatever the systematic manner that you are going to order them, and from that order you are going to select. Now does that order has to be coming from a very extreme method, like let's say height of people or maybe weight? That doesn't necessarily have to be the case. You want to just put them randomly on a sequential order, and then from that order you know that you have to select the 8% out, then the 16% out, 24th, 36. So likewise, you have to take every 8 passenger out of the 8 in a row, and then uh, and cultivate your 50 sample size, the simple N. So what is the difference between this versus the previous sampling method of simple random? Here, we don't have a organizing. We don't really, go and put things in an order. Rather, we use a random number table and then merely select this n number of chaps to the simple population. But here, unlike that, in a systematic order, we put items in the population and then determining on the previously determined sampling fraction, we select the uh, nth person or nth item to be selected in our sample. So this could be also one of the very let's say scientific method to select people to be represented into a sample. So why do we do that instead of simple random sampling? Because at sometimes this may give a greater chance for the population, uh, for the sample to be enriched with different types of personnel to be represented in our sample. Because that previously we discussed that when we put chaps on a random selection, sometimes there will be a huge disadvantage of selecting a couple of biased people. But still I'm going to ask the same question. Can you say by selecting the 8th passenger in this sequentially order, can you omit the biasness from this sample? Still my answer would be no. Let's say you are going to now in this particular study of these 400 passengers and 50 sample size. Okay? Let's say you are going to study on this airline. Let's say it's a Boeing 747 and 400 capacity is possible in that plane, and you're going to see the nationality of the flyers on a random basis. Of course, you can talk to the flight crew and get the data on the entire 400 passengers and see what sort of geographies that they're representing. But let's say, interestingly, you're going to do this study and you're going to select 50, and based on that 50, you're going to come out with a result saying that this is the representation of the geographical representation of my passengers. But what if, what if every 8th person is an Indian? For instance, we see a lot of Indians flying these days. What if this 8th and 16th and 36th and likewise, what if this every 8th person is an Indian randomly? Still there's a random chance that your population, your sample will be completely biased. So again, I iterate the fact that when we want to select 50 out of 400 in mathematics, you say 400 C50, the combination selection method could give you hundreds of different types of combinations of these chaps to be put it into the simple n. But some of them will be completely disastrous or completely biased samples. So bear in mind. But those are very few chances. But the greater chances are your eighth person will be perfectly randomly selected national. The first may be a Chilean, the second may be an Indian, third may be an American citizen, the fourth may be a British. So likewise, your eighth, when you do a sequential ordering, depending on the height or weight or the time that they arrive at the airport, whatever the sequential, that doesn't necessarily matter here. However, it has to be sequentially ordered, not like a random selection. And then when you do the picking from a systematic way, your sampling will have a greater chance of having the non-biasness. Okay. Cover two, probabilistic method. Let's look at the third and fourth. These are the sampling methods which have a very thin margin among each other. So we'll try to carefully understand what these are and uh, the differences and the similarities. Okay. Third one is the stratified sampling method. In here, the population should be divided into homogeneous and mutually exclusive groups called as stratas. Okay. Homogeneous means it should have the similar characteristics. Mutually exclusive means that characteristic cannot exist in the same person at the same time. Look at these faces that I have given in this picture. You can see the blue color faces are happy. Red color faces are not happy and white color faces are indifferent. What do you mean by this homogeneousness is that you can't have these smiling faces and indifferent faces or indifferent faces and angry faces at the same time in the same person's face. So you will either have a straight line, either have a negative face or a non-happy face or a happy face. That means depending on the characteristic, you can cluster them into different stratas or segments or groups. Okay, that's the understanding. It has to be homogeneous and mutually exclusive. So that particular selected characteristic cannot be existing in the same person at the same time. So these groups are called stratas. Simply nothing but a group strata. Examples of this strata could be age, gender, geographical segment, likewise. Okay. So this may be, let's say, youngsters, elderly, and infants. Or this may be from the Asian continent and American continent and maybe Australian continent, likewise. So you can't, put somebody into two different stratas at the same time. One person or one item should be in one group only. Okay. Now that is done. So stratification or the grouping is done. Now the second step is for each strata, for each group, collect samples by simple random sampling or systematic sampling method. So once you have a particular group, then from these groups, you can do a simple random or a systematic sampling. So that means from each of these groups, you are going to select some elements to be represented in the simple. And now look at this example of 9 chaps in this picture. You have selected 3. So it appears that from each group, you have given 1/3 of an opportunity for somebody to be represented. That means from this group, this left gentleman or lady is taken. From this group, this right top one, and the bottom group, the bottom one, is taken into our sample. So the whole idea is that now in this instance, you know some particular characteristic about your entire population. So once you know that, based on that particular characteristic, you define them into particular groups. And once that groups have been defined, you use one of the random sampling method to select items to your sample by each strata. So can you omit one of these stratas? No. Stratified sampling always suggests that from each of these stratas, you're going to select at least one or maybe one third or maybe 10% or whatsoever number, depending on your choice. So each of these homogeneous groups are given an opportunity to be represented. That's the whole idea of our probabilistic method, isn't that so? We have to give an equal opportunity for the items to be selected in the sample. Okay. That's about the stratified sampling. Okay, be careful. The stratified word is repetitively seen in couple of places in past paper examinations also, where you will be sometimes misleaded with the quota and sometimes you will be misleaded with this next one on the cluster. Let's see what the cluster sampling is all about. In here, we have to divide the population into groups. Similarly, like in our previous example, in the previous stratified method also, we divide them into groups and obtain a simple random sample of clusters from all possible clusters. Now, if you look at the previous grouping of stratified, I'm sorry, I'm changing slides again and again just to show you the differences and similarities. Rather, if you by heart these things, I repeat, you will be not at a very comfortable position. Rather, we'll try to understand how these names are being derived and the similarities and differences. So you will be very comfortable. So in this previous stratified method, what we did was we defined the groups based on a homogeneous characteristic, and then we gave an equal opportunity for everybody to come into our sample. But here, the only difference is that once you do the grouping, depending on like the similar case, depending on a homogeneous characteristic, the same element cannot be represented in multiple clusters. So all these conditions are still there. But then for the sample, for the simple n, you are selecting this entire cluster by cluster for the study. But here you may see that, let's say in this example, you have red chaps, green, blue, and purple and yellow. But then if at all you're going to select everybody from this, this thing, so this is again not going to be a sampling. It is a selection of population, isn't that so? So rather, you group them, and from these groups, you select couple of groups to be represented for the survey. Couple of groups. So this instance, you have selected the red group, green group, and the purple group to be in your sample. This entire set of clusters are being, let's say you have 27 clusters. From these 27 clusters, you have selected maybe 6 clusters to be in your sample. So the entire cluster comes into the sample. Above is called one-stage cluster sampling, while if we conduct another simple random sampling from the selected clusters, this can be defined as a two-stage cluster sampling. So what do you mean by that is, as the first stage, we take the red, green, and purple elements into our filtration. So from this filtration, again, rather taking this entire 6 red chaps and 3 green chaps and 5 purple chaps into our sample, rather, if we do another simple random sampling and select maybe 2 from the red, 1 from green, and 2 from purple, we can call it as a two-stage cluster sampling. So that's just a definition. It could go to more stages of cluster sampling, depending on maybe more methodologies. But the whole idea is that the cluster sampling itself is suggesting you select, say, many number of groups or clusters, and few clusters can be taken into consideration for the study. If you could recall my very first couple of examples ago, I quoted this example of 50 villages case. Could you recall that? We are going to select a couple of villages to be in our study. Now that could be a classic example of cluster sampling. We are given 50 villages. Some are at a very remote states and some are at a very urban state, but still we are going to go and select 5 villages for our study. So a village is an entire cluster that has men, women, children, everybody. So, But from that village also, if you go and select some chaps based on another random sampling, that is the definition of two-stage cluster sampling. But the definition I have rarely seen being tested. But the broader idea of cluster sampling, if you could, engrave in your minds, that is fairly enough. Again, I reiterate, what's the difference between the stratified and cluster? It's nothing but stratified, you're giving an equal random or a stratified, uh, sorry, random or systematic sampling method from the groups to select the items into your selection. But here, the broader idea is that you have many clusters. From those many clusters, you select few for your sample to be represented. So few times ago, if you could recall, we discussed something under quota sampling. Here also, see, we divide the population into some known areas, but we select the sample based on our choice, based on the researcher's choice. But unlike in that area, the stratified and cluster, we are selecting few based on a random method. Now, in the selection of red, green, and purple also, I didn't mention that it's based on our choice. So it has to be on a random choice. So maybe you are giving a few names of, let's say, you don't know this t-shirt wearers as red, green, and purple. Rather, you give them cluster 1, 2, 3, 4, and 5. And maybe based on a random method, maybe a random table or some random numbers, you select 1, 5, and 4 for your this thing. But in the previous, the quota method, it's not like that. You divide them into groups, but then again, you use your judgment to have your desired mix in the sample. Okay. So that's broadly on. We spent good 1 hour close to defining these individual sampling methods. I hope you had a broader understanding on what these sampling methods are and when some of these sampling methods can be very useful and we have to use them. This is one additional slide I've just put to graphically illustrate the 4 probabilistic sampling methods that we learned a moment ago. Look at the first one in the left top corner, the simple random sample. It suggests that depending on a random number table, you're selecting some random elements. So sometimes you may see a greater sample, but sometimes you may see a bias sample. Systematic sampling is that nothing but we put everything in an order or a nice sequence. And then depending on your sampling fraction that you define, depending on that, you select the nth item, the 8th item, the 10th item likewise to craft your sample. The stratified sampling is where you define different groups depending on the homogeneousness or mutual exclusiveness of particular characteristics. And from those groups, you use a simple random or a systematic kind of a method to select few elements to define your simple N. The cluster sampling, the last one, is nothing but you have many clusters and depending on a random number generation method, you select few clusters randomly, cluster number 2 and cluster number 3 to be your sampling. Cluster, the further extension is that even inside a cluster, if you do another simple random sampling, you can sometimes call that as a 2-stage cluster sampling. You select a cluster and from that cluster, randomly again, you select few elements. That's the broader graphical illustration on the probabilistic sampling methods. The fourth area I want to discuss, these are some of the possible issues with sampling, and then I'll take you through one example of some practical difficulties when you are selecting a sample and how your sample is going to be depending on the availability and the true and fair representation of data. But before that, these are some of the broader possible issues with sampling. I invite you to make a small notation here. Now, this is a very favorite area of the previous examiners for some questions to be put into your examination paper also. But broadly, the very first issue with sampling that we discussed throughout this probabilistic and unprobabilistic methods is such that you can't perfectly define the simple n to be the perfect representation. You can't achieve 100% representation of the population at any cost. There's a very thin probability that you can select that perfect representation, but 99% of the time your representation will be somewhat biased, will be weighted, will be under or over represented by a certain element. You can't really omit that. But still, we are using sampling method. So, but knowingly why we are doing that is because of the practical difficulties. So, these are some of the possible issues with sampling when we do this sampling exercise, unfortunately, due to the practical problem. The first one is the coverage error. It says the sample is not representative of the population. That is the very broader issue with sampling, which we discuss again and again. So because of that, if you do some study, there is a very high tendency that your end result will be somewhat biased. So can somebody think of a suggestion to omit the coverage? One could argue, okay, if my sample is not going to give me a perfect coverage, what if I take another sample? Now that's a very good suggestion. I select some elements from the population, finish the study. Then I conduct the sampling study again. Exact same questions. And again, I put forward to the population and to the next sample, and I take out the questions. So I do the third round also, some further elements to be selected. So now in these cases, it's not like that, in our, let's say there's 70 students and taking 5 into study, and I'm taking 5 randomly, giving them some questions. Then I take the data for the analysis, and then I throw those 5 students back to the 70 population. It's not the case. Uh, for that to be, otherwise I will be taking the same person twice and thrice, and my survey will be filled with the same response again and again. That's not the case. I have to take that 5 out, and from the rest of the 65, again I have to select another 5. Then the rest of the 60, another 5. Then that will be giving me more data for the analysis. But maybe at the third round I'll stop saying okay, fine. Otherwise, if I continue, it may be 12 times that maybe I'm covering the entire population. So that's not the exercise. But in a very broader coverage issues, one of the suggestion would be to do the sampling again, select some more subjects, and get more responses. Second one, sampling error. When a sample selected by a non-probabilistic method. So this is where when you select a certain set of elements from an unprobabilistic method, you will be getting a erroneous set of chaps in the simple n. So broadly, if you look at the coverage error and sampling error, both are discussing the same thing. The coverage error is saying that it is not the perfect representation, but the non-probabilistic methods, the broad idea is that you are selecting subjects into your simple n based on your choice or the preference. So when you have a choice or a preference, there's a greater error called sampling error, which can have some sort of a negative outlook on your sample. Rather, if you use a probabilistic method, the sampling error is minimized. Why? Because that you previously do not determine what items to be selected in the sample. Rather, you give it to the probability, you give it to the random numbers to be selected to the sample. So the sampling error could be minimized if you use a probabilistic method. So broadly keep in mind that the word sampling error comes into play that if you use a non-probabilistic method. The third one, the measurement error, is because of the leading questions. So students, if you look at some of the questionnaire that you've been put up with, sometimes you may see that these questions are being defined in a way to give you a leading indication to the answer. So maybe unknowingly, your question will carry some hint towards the answer. So if the majority of your sample gets that hint and okay, select that particular answer, now that is going to give you an indication which we call as the measurement error. That indication is giving because of the incorrect and leading questions. Let's say uh, a good leading question would be something like this. Do you think if you wake up at early and study, you will have greater marks? So obviously, a majority will think that getting up early and doing studies in the early in the morning will be much more advantageous, because that's one of the methodologies that is inculcated in our mindset from the childhood days, saying that you have to wake early and do your studies. Then it is better compared to you stay up at the late night and do your studies. So that leading edge, I mean, the question itself suggests that, do you think that if you have been given a chance to wake up early and study, will you be getting good marks? That leading edge is indicated in the question itself. But if the question is worded in a different way, uh, which method do you think is the best? Method one, wake up early in the morning and study. Method two, stay late night and study. There's a fair chance that some people will choose the late night and some people will choose the early morning. Maybe 50-50, maybe 60-40. So that question will have a greater measurement. But that leading indicator, if you put it in a question, like, do you think if you wake up and your studies will be better? Obviously, majority, it will be a 70-30 or 60-40 case at least, because majority, whether you do it or not, will say, okay, that will be a better. That's the measurement error that also comes from the incorrect or leading questions. If the question is incorrect, forced into a dead end at the end, you will be obviously choosing that dead end answer. Or a leading question, it will be again coming to an some sort of a biased answer. So the broad idea in the measurement array is nothing but your answer will be biased or channeled or narrowed to a particular segment because of the way that question is being put up. Okay, the measurement error is a word that has been questioned in a couple of times in the previous past papers. The last possible issue that we can discuss is called as the non-response error. This is due to respondents providing fraudulent information or not providing information at all. Now, some of the questionnaires, I'm quoting questionnaires again and again because that's one of the easiest or most widely seen methodologies that we could see researchers are collecting data from a sample. So, talking about a questionnaire is the best way to understand that why these issues and errors are coming from. Okay, so this non-response error is sometimes say some questionnaires you may see that you can answer questions the way that you prefer. Those are not mandatory. Some questions you can just omit and go, and you will, psychologically you will love to not answer everything and finish an assignment. But sometimes all these questions will carry a red asterisk mark and saying that it is compulsory to answer these questions. And at these instances, you can't move to the next level. So you may at least put some information and try to move on. So this is the exact instances where you will find this non-response error. The previous instance that I said, falling into not providing information. That means you're given a choice not to give the information in a mandatory way. Some respondents will try to omit that question and move forward and finish your questionnaire. But sometimes, say provided you're mandatory to put up information, or sometimes intentionally. Some people, when you're responding to a particular survey or study, Some will say, I don't prefer to give this answer. I will give you just fraudulent answer. If you just try to get somebody's mobile number, there'll be some sort of an uncomfortness where I will be focused on some advertising material, or somebody will take my personal number and call me for information. So likewise, so provided that you have been not assessed at one point, there's a greater chance that a fraudulent mobile number could be present. So, likewise, this non-response error is emerging because of the uh, appetite or the psychology of the respondents in our study, right? So, these coverage, sampling, measurement, and non-response errors are some of the greatly discussed sampling issues, but these are not the only types of issues. There could be many sub issues that you can and cultivate from this. Broadly, coverage is nothing but you can't come up with the perfect population. Sampling error comes into play at all the instances on the non-probabilistic methods. It's a classified term that we used as a sampling error. The measurement error is coming because of the leading question or some incorrect put questions, and non-response error comes into play if you provide fraudulent information and if you do not provide information at all. Okay. So that's about the idea on the possible issues with sampling. Before we move into a couple of questions and close it for the day, I just put this slide number 18 to show you uh, a practical instance. This is I am hypothetically trying to say that okay, I'm going to select some students from a target university, and I am going to and cultivate a simple N from a capital N. That means the entire university students, and see what kind of a result that will be coming into play. Okay. The first thing, target population. My consideration is uh, it's a general characteristics. So I am not very keen on selecting any criteria. My target area is a general characteristics should be university student between age 25 to 35. Okay. So I go to a particular university, let's say University of Colombo, and then I'm going to target students between 25 to 35, maybe doing their masters and PG diplomas and so on and so forth. So the second one, the accessible population. Uh, Now this is going to be some other constraints that is going to come if I put up this consideration. Okay, that means when I go to this study for the university, when I'm going to select the students, there is a possibility that some of them are not present today. So although my target population may have, let's say, 250 students between age 25 to 35, maybe 200 or maybe 150 may have attended that day. So the accessibility is going to give a constraint or an issue when I'm going to select my population. Okay, so I start with 250, and then I am going to select some students, but unfortunately maybe I have to omit 100 because that they're not present today. Look at the third criterion I'm looking for, inclusion criteria. Now here I am just trying to put up a criteria to select a particular set of items in my sample based on a characteristic that is in that particular students. Now my example is international students. So out of this 150, there may be broadly, now we started 250, right? 100 are not present that day, 150 is here in my accessible population. So when I put my inclusion criteria as international students, I may be left with 25. So out of 150, 125 may be local students, Sri Lankans. So 25 may be the students that I can include in my criteria based on this definition of international students. Okay. Lastly, similar to inclusion criteria, I can design some exclusion criteria also. Those are some factors which will not inside the particular characteristics. The example is non-English speaking students. I'm looking at maybe Mandarin and Russian speaking kind of students. Okay. So out of that 25, again, I may be left with uh, 5 or 6 students. Now look at the way that I'm trying to cultivate my sample. If I just focus on the entire population, I can talk to these 250 students. But still, when you look at the practical issue on accessibility, at that particular day, I maybe only have 150 students. And then if I put inclusion criteria and exclusion criteria, again from that 150, I may be narrowing down to extreme less number of items to be selected in my sampling. So can that be a good sample? No. In that case, I may be at least out of 250, if I can get at least 25 or maybe 10 for my study, that may I may determine that as a good fraction, good sampling fraction to be taken into consideration. There's no right answer for this sampling fraction. Even if you take 4 out of 250, one could say, okay, that is all what I need. But still, I just want to highlight that if you put these criteria on accessibility, inclusion, and exclusion, your sample will become smaller, 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 and narrower. And sometimes the accessibility could kill the entire this thing. I mean, at that day, you may have out of that 250, you may have non-English speaking students, maybe 15. But if each and every of these 15 are not present at that day, you can't do the sampling exercise because of the accessibility constraint taken into. So now this is a classic example or some I would say criterion to be considered when you're doing a sampling exercise. The accessibility, inclusion, and exclusion criteria can sometimes lead to a very smaller sampling size, or sometimes your sampling simple n can be ultimately become zero because of the non-presentness of items in the sampling. Okay. All right. So we covered the entire area on sampling. Let me quickly go back to the content page and do a quick recap up to what we studied, and then we'll spend a good 20 to 15 minutes on some of the examination questions and trying to look at the examiner's suggested answer and see why they are the correct answers. And if you have arguments, I'm more than willing to take it up. We discussed broadly onto the sampling methods. We discussed non-probabilistic and probabilistic are the two major branches we can broadly see in the sampling methodologies. Non-probabilistic, you do not necessarily need to know information about the population, while the probabilistic is that you need to have some understanding on the characteristic that you are looking at a particular sample. And then convenient, judgmental, quota, snowball are some of the examples on the non-probabilistic. Convenience is nothing but the accessibility. Judgmental is you are selecting based on your pure judgment. It's not like the accessibility, but your perspective. Quota is similar to stratified. We said in the probabilistic method, we cluster them based on some sort of a mutually exclusive criterion. But then we judgmentally define the criterion to select the simple n from the capital N. We do not give an equal chance like the stratified, but rather we judgmentally select the quota under whatever the criterion we want. Snowball is very easy one. You recruit the first one, and like a snowball, the second, third, fourth, 10th elements will be coming into the sample. The second set of probabilistic sampling suggested that the broader idea is that every item in the population should be counted for, the criterion should be defined for, and equal probability should be given to individual items in the population. The most widely used is a simple random method. You define a simple, you name items in the population, you define a simple random generation process, and from that process, you select second 8 likewise items. Systematic is you put them in an order, and from that order, you define something called a sampling fraction. 8th, 10th kind of items will be taken out from the nicely ordered items, and you can cultivate the simple n. Stratified is you define, similar to the quota, you define the groups depending on the criterion, and from these groups, equal opportunity is being given to select items to the sample. Cluster is nothing but similar to quota and stratified, you define smaller groups, but the group itself is taken into consideration. But one further step, cluster, you can go to a second stage if you use a simple random from the cluster itself. But broadly, cluster is nothing but you selecting the total cluster. And then we discuss few sampling issues like sampling error, non-representativeness, coverage. Likewise, irrespective of these 8 methods that you follow, these issues will come through at any stage of the sampling exercise. Okay, so that's the theoretical part of the day, and we will see what sort of questions that is being forwarded by your previous examiners in this subject matter. Okay, so broadly, you may see in the previous week at the last part we discussed question number 8 is popular among examiners. Question with an open-ended statements like do an explanation, do a compare and contrast, give some information, write your opinion. Likewise, so if you could recall the examination paper that I've got at this slide number 19, 2019 September paper. If you could recall last week discussion, look at part number 2 and 3. Part number 2 is suggesting qualitative data and quantitative data. Part number 3 is on primary and secondary data. Now students, these are nothing but big 5 marks questions. So as long as you are very thorough on defining these elements in a very brief manner, not by very lengthy answers, you have ample opportunity to score 5 out of 5 from the suggested answer. Okay, so if you look at the if you look at the fourth part of this question, this is related to what we studied this week. Give a second. Right. The question says statistics involved in various types of data, so on and so forth. Briefly discuss the following concepts related to statistical information. Now, the question suggesting not to distinguish between anything, but briefly discuss the following concepts related to statistical information. The word discuss suggests that you should write some broader definitions, some examples, and some insights into what these things are. Look at part number 4, simple random sampling and stratified sampling. So we discussed these theoretical areas a couple of times. So it is all about you writing for simple random sampling. It's a probabilistic method. Stratified sampling is also a probabilistic method. So under simple random sampling, you name the items and then you select your sample based on a random number generating methodology. It could be a table, it could be any scientific methodology, and those items will be taken into your sample. Still, there are some errors. So that kind of an answer is enough for a 2.5 for the simple random definition. Stratified sampling also, you could say, you put them in a nice order. Depending on your choice, you can select the sampling fraction. Now, those wording is not essential, but if you use those wordings, examiners will be very delighted to give you the full marks because you are using the jargon used by the mathematics and statistics people. Okay? So this, depending on the fraction of your choice, you select the nth item. Put up a small stick and a man kind of an example. Some sticky man, I hope you understand the ball head and the arrows will define somewhere. So you put some 8 or 10 such and then highlight the 8th and say you're selecting the 8th from this row of 80 or 100 pens. That's a classic answer for stratified sampling with that example, right? So I hope you're getting slightly more comfortable now. When you look at the question number 8, you will see broadly this question is coming from definitions and rather discussing the concepts from your perspective, rather giving statistical or mathematical numbers. But bear in mind, don't carry away that each and every question in the paper is similar to question number 8, but classically, question number 8 is giving you an ample leeway to score marks at the exam. So I strongly invite, if you're good in your definitions and measurements, you can select this question. We can see a couple of more questions. I'm moving to slide number 20, 2019 September. Question number 1. Now, students, I repeated at my first lecture. I repeat. Question number 1 is compulsory. So these MCQs and open-ended questions, couple of 10 questions will be there, is compulsory. So there is no escape. You have to answer them to get 20 out of 20. And bear in mind, these questions are not very tough. You can't put up a very complex NPV calculation or a detailed treasury bond discounting kind of a one, or a, for that case, some variable multivariant analysis kind of a question, but rather merely some theoretical testing, or maybe a very small computation will be tested for these 2 marks. Okay, so this is one such question. 2019 September, the last question paper we had, subpart number 2, question number 1. In a sample survey, every 10th individual from the list of all employees of a factory are planned to be interviewed to find out their views on the present retirement benefits. The name used to describe the sampling method is. Now look at the question again. Every 10th individual from the list of all employees. List. Look at the word list. So it seems to be an organized chain of names. So every 10th person is being taken out. The moment nth word comes into play, you can say it is nothing but systematic sampling. So the answer would be answer B. Okay. I think mistakenly you did mention here under stratified sampling, that stick-in-a-man example that I have mentioned is nothing but the systematic sample, but bear in mind that this is the stratified sampling that has been asked in the previous question. So simple random sampling that I mentioned is correct, but the stratified sampling is nothing but what I explained, like a stick-in-a-man example that I've quoted like in here. For the case for stratified sampling, this is the answer that you have to draw for your example. Rather, it's not like selecting the n person, rather you cluster them into mutually exclusive groups and giving some equal chance to be selected to the sample. Sorry about that. I think I also misread the question. I saw this as systematic sampling. Sorry about that. Okay, that is 2019 September, question number 1, subpart number 2, MCQ. Quick question, straightforward, 2 marks. Look at this question, previous question paper to that. 2019 March, again question number 8, the last question of the paper. Statistics involved in various type of data collected from various methods and sources. Briefly discuss the following concepts and concepts related to statistical information. The examiner is asking the discuss, not compare, contrast kind of where you have to find similarities and differences, but rather do a definition, some example, and some write-up. Look at them: simple random sampling and stratified sampling. So if you look at this question, isn't that the same question we repeated in 2019 September? It seems to be, isn't that so? 2019 September, question number 8, subpart 4 is asking for simple random sampling and stratified sampling. It's the exact same thing. So that's why I said that there are a couple of styles in sampling where examiners give you a preference. And even I misread this previous one as a instead of stratified, I used as a systematic sampling. So be very careful of the definition that you're putting up. And I would say quota, stratified, Simple random are going to be some heavily tested sampling method. So briefly, once again, give the definition, some explanation, and if at all you can put up an example, that's perfect for this. Look at the fourth one, measurement error and non-representative errors in conducting surveys. Now, we discuss four, measurement, non-representative, sampling. So look at them. Measurement error, non-representative error, you can merely put up the definitions and put up some examples like due to reading questions and incorrect questions. And for the non-responsive errors, you can put up due to the preferences or due to various reasons. People will give faulty answers or not answering at all, can lead to errors in the corrected sampling data. So bear in mind again, last week also I iterated that for 5 marks, there's no exact measurement of length or number of lines that you should answer, but your answer should broadly consider the definition, the idea, some examples, and some wording. That is more than sufficient. Okay. Let's look at this question, 2018 September, question number 8. Statistics involved in various types of data, same thing repeated. Briefly discuss the following concepts related to statistical information. Again, question number 3 has asked for the same thing that we discussed a moment ago, measurement errors and non-responsive errors in conducting surveys. So you can broadly answer that now. 2018 March, question number 8. The same thing. Briefly discuss the following concepts related to statistical information. Again, it is asking simple random sampling and stratified sampling. So two sampling methods, you can put up some examples and definitions. That's perfectly fine. 2017 September, this is coming as a compulsory question, part number 6 for 2 marks. Let's read and see. Suppose you're performing stratified sampling on a particular population and have divided it into strata of different sizes. Strata are nothing but groups. Okay. On a particular population, the question itself is suggesting you're doing a stratified sampling, so there's nothing on the sampling methods, but it is clearly said. You can now make your sample selection by now the stratified sampling suggested that we define the stratas based on mutually exclusive characteristics and then give equal opportunity from the stratums to be selected to the population. Look at statement number 8. The question is suggesting which of the following is correct for above statements. So statement A, B, C, we'll read and see which of seems to be correct and which seems to be incorrect. Statement number A, selecting at random an equal number of elements from each stratum. B, selecting equal number of elements from each stratum and weight the results. C, selecting numbers of elements from each stratum proportionate to their weights in the population. Okay. Now, look at part A, B, and C. Let's discuss an example to see what the examiner is trying to discuss here. Now, when you do a grouping, now if you could recall our previous example, let me quickly take you there. Sorry. From here, now this is a classic example of having the exact same number of items in the same group. But what if we have more items? Let's say so even though this is on the cluster sampling, but for the moment, let's say now these also groups. This red group has 6, green group has 3, the purple group has 5, so on and so forth. Okay. Now these stratas of the clusters will have different numbers of elements. It doesn't necessarily have to be same number of items in the group. Okay. So having this picture in mind, we will quickly come to our discussion on this particular question, 2017 September. Statement 8 says selecting at random an equal number of elements from each stratum. Look at this equal number of element word. Now, that 3, 5, and 6 groups, if you select 3 from every stratum, it is not again giving an equal probability for every group to be selected. Isn't that so? The stratified sampling is all about giving an equal opportunity for everybody in the population to be selected to the sample. But look at the statement B and C. The B says selecting equal number of elements from each stratum and weight the results. That means you take 3 from each, and then based on the proportion or percentage or weight of each of the group, the results should be weighted. Now that seems to be pretty much accurate on the concept of stratified sample. Statement number C also say select a number of elements from each stratum proportional to their weights in the population. That's also perfectly fine. Now in our diagram what I have put up, you have 3 from each group under the stratified. But if you look it in a real world example, the group A may be having 60 elements, group B may be having 40 elements, and group C may be having another 100 elements. So based on the weightage, the group A will carry 30%, group B 20%, and group C will 50%. So based on the weight, you have to select 3, 2, and 5 from this 60, 40, and 100 in the real world example. So answer B and C seems to be pretty much in line with what we can see under the stratified sum. But if you go for answer number A, the difference is if we select equal number of elements, then we are overweighting or underweighting certain stratum. So that's the thin margin of the definition in the stratified sampling. So under that circumstance, you can select for 2017 September answer number B as the correct answer. Only B and C are true. Okay. Now look at that question. Even for a 2 mark, you have to have a clear understanding on the thin margin of definitions on these questions. Okay. Look at 2017 September question number 8. Briefly discuss the following concepts related to statistical information. Again, asking about cluster sampling and stratified sampling. Students, again, these are definitions that we learn. So that's now 2017 March paper. If you look at the question number 8, similar definitions. Now this question, be careful. We're asking about the examiner is asking for a compare and contrast. So in that case, you can't merely write some characteristics. You have to write the similarities and differences between these two elements in either side by side or in bullet points in a nicer representative manner. Okay. The main question 8 is asking about simple random sampling and stratified sampling on part number 1. Part number 4, measurement bias and non-responsive bias in encountered in sampling situations. So I believe you are in a good position to answer these theoretical questions. But look at question number 1, subpart number 4. What is the best sampling method to be used in a survey related to wages in apparel industry where there are male and female workers? What is the best sampling method? The moment we are being given the best sampling method, you have to always think, okay, that seems to be indicating on a probabilistic method. As we said, under non-probabilistic method, the sampling error can always be visible because of the biasness of the selection. Okay. So if you look at the definition of this population, it says that and the apparel industry where the male and female workers are there. It seems to be grouped, isn't that so? So the word on systematic sampling and random sampling seems to be fairly somewhat deviated from this given circumstance. But what if we selected stratified sampling or quota sampling in that case? The quota could be a good example, but if you look at the definition on stratified could be one of the best methods. Why? Because of the fact that you are giving an equal opportunity under every cluster or strata that you will be defining. So in this survey, you may be defining from factory wise, and then you may be defining clusters from male workers and female workers, and then giving an equal opportunity from each group to be represented for the survey. So I'm suggesting answer number A is going to be the best sampling method. 16 September, similarly, asking compare and contrast probability sampling techniques of simple random sampling and stratified sampling. Measurement error, non-responsive error. Again, theoretical parts. Last question I'm going to discuss. 16 March, question number 5, compulsory question. In a sample survey, all employees of a factory are planned to be interviewed to find out their views on present retirement benefits. The name used to describe this sampling method are. In a sampling survey, all employees of the factory are planned to be interviewed to find out their views. So when you say all employees, this sounds like the entire population is being defined as a factory. So one could argue, okay, if I'm interviewing all employees, what's the involvement in sampling? So isn't that I'm going for the entire population? But bear in mind that the examiner is trying to trick you here, suggesting that all employees are taken into consideration, but a portion will be taken for the sampling, and then from the sampling, they will determine their views on the present retirement benefits. Okay. So one could say, right, what if we do a simple random or a quota in that case? So the quota will be more or less, you will be defining different quotas. But the question is suggesting, it seems to be not the case. You're not defining any particular groups and giving some guidances. It's not the case. Just the question is suggesting that some sort of stratas are being selected and trying to give some equal opportunity. That's also not being indicated. Random sampling, is that the case? Then the wording should be randomly some employees will be selected. That's also not being mentioned in the case. So lastly, we will be left with the option of cluster sampling, because merely under this circumstance, employees will have to be clustered, maybe depending on their geographical representation, maybe gender, maybe the age group, and then from those clusters, some selection will have to be taken. I have cultivated that answer merely by deductive reasoning. If it is stratified, I have to see whether some sort of a grouping and weighting is given. It's not indicated. Randomness is also not indicated. Quota, giving some allocation depending on the choice is also not given. So in that case, all what is left for this to be deductive reasoning orientation would be nothing but the cluster sampling should be the method that they have followed in this instance. So that's a good tricky question. 2016 March question number 1, subpart number 4. And sometimes you may think that they may have done one of these other methods, but there again you have to be careful to carefully go through this word and see whether this randomness, some allocation, some scientific methodology, or some judgmental quotation has been given. In that case, if none of them are not visible, then the only logical thing would be the answer that is left. Okay, lovely. So that's about it for the today's session. I think we are done with the lecture on complete lesson number 1. So with this, we are finishing lesson number 1 completely, and then we will be moving to lesson number 2 from next week onwards. So from lesson number 2, 3, 4 and onwards, we'll be going through some numerical questions. We'll be using the board heavily. You will be invited to go through some of the computations there. Keep in mind of some of the equations. Don't worry, I will highlight all these individual and important equations which will be used in the examination. So you don't have to worry much on the previous previously tested questions. Rather, you will just move ahead with the question oriented equations and try to score the best marks. So I'll open the forum for a couple of minutes, and for those who have no questions, have a good afternoon. But if at all you have a question, you can voice it out or use the chat section. I'll leave a couple of minutes here. Was my audio clear during the lecture? I see a couple of chats saying that it has not been clear. I'm sorry about that. Yeah, for the last question, can't it be stratified? Uh, of course, it could be stratified also, but then again, uh, Abhishek, they have not mentioned that they have done it in that way. They have selected the groups and they are giving some equal opportunity. Broadly, it says that they are going to select uh, some of the chaps from the factory and conduct this testing. So if it is to be stratified, I suggest that the question should mention that they should be clustered into groups and give some fair presentation. So that's why I suggest that we can't go ahead with the stratified. So we are only left with the cluster. We can sample underage. They have mentioned as retirement. Yeah, of course. Now, the study that they're conducting is on the wage on the retirement. So, I mean, that's their study, their views on the retirement. But then again, that doesn't necessarily say that we have to select some chaps based on a particular criterion and giving some equal weightage. So if that is to be stratified, I suggest the examiner has to mention that I am going to group them and give some equal probability. So true, your argument is very valid and it is nice. It says that it's on the retirement views. You can, of course, you can, but it's the examiner is the researcher, so he hasn't specifically mentioned. So in that case we can't really go ahead with the stratified. It's a nice question. I suggest you read it again. And yeah, Isuri is asking the same thing on the last question. Why I selected the cluster sampling is nothing but because of that other three, they have not specifically mentioned at the exam. I mean, the examiner's wording, if you carefully see, for you to select that that particular factory has done stratified or simple random, they have not indicated that the selection will be done based on individual method. Rather, the only left over will be the cluster sampling. That's why I have to go with the answer D. So if at all the question says that I am doing the research on the this thing on the retirement benefit, and I am going to group them and conduct my survey. Of course, we have to left with the cluster and stratified, and we have to argue which one is the best. If the question say randomly selected employees will be subject to this interview, then it could be simple random. If the question says depending on the attendance sheet, we are going to select some nth person, 10% or 14%. Of course, we can go for the systematic, but none of them are mentioned. So that's why I say it's a very nice question. So we have to be, you have to assume that it has to be, they are going to take the cluster method. There are more questions, of course. I think close to the examination also, I'll try to take some more questions from the very deeper examination like 2013 and 14. Some of them are not maybe directly related to your current syllabus, but rather interesting questions are there specifically on this section. We'll try to cover some more questions, specifically a couple of MCQs, and try to argue in different ways and calculate your knowledge. Okay, then. Thank you, everybody, for the interesting session. Hopefully, we'll meet next week with a new lesson. And beforehand, I'll try to. I mean, the next lesson is a very straightforward one, and I would say it's a very lethargic one. It's on the data representation, charts, and graphs, and this. I mean, there's nothing much to be, discussed as a lesson, but you have to learn some of the basics, and you have to understand how to draw certain things, how to represent, what the perfect way to represent. That's also under part of your learning. So I hope you will be with me on the next week. We will finish it up. The next lesson will be just one lesson, lesson number 2, just one lecture. Then we'll be moving to lecture number 3 on interesting areas. Okay. So thank you, everybody. Have a good evening. Stay safe and cheers. Bye.